Welcome to Video Assist. This lesson deals with Lenz's law or electromagnetic induction. It can be found Unit 3, Section B, Activity 5. Before we look specifically at Lenz's law, we have to be sure that we understand the right-hand rule, the second right-hand rule for a coil or helix. I've drawn one here. In this case, the current is flowing as shown. Using the right-hand rule, number 2, one can determine the polarity of the magnet or electromagnet that is produced. The rule says, take your right hand and place your fingers or align your fingers with the flow of the current. So that would be something like this, as if I'm wrapping it around like this. The extended thumb will point towards the North Pole. This would be south. If you understand the second right-hand rule, then you're ready to discuss Lenz's law. Lenz's law deals with a changing magnetic field close to a coil. We can change the magnetic field close to this coil by moving the bar magnet either in or out of the coil. Suppose we move it in. As we move the bar magnet into the coil itself produces its own magnetic field which opposes the motion of the bar magnet. Since north repels north, the coil will produce a north pole at this end of the coil and a south pole at this end. Which way would the current have to flow in the coil to make this a north pole? We have to use right-hand rule number 2, which says point your thumb in the direction of the North Pole. Your fingers will indicate the direction of current flow. I'll point my thumb in the direction of the North Pole. The fingers wrap it around the coil, and you'll notice that the direction of the fingers on top of the coil is this way. So I'll mark in that direction as being to the right. On the other hand, if the coil is removed, if the bar magnet is removed from the coil, as shown here, the North Pole here is being removed, so the coil will produce a South Pole so as to try to attract or make it more difficult to pull out the North Pole. That makes this end north. What direction would the current have to flow in the coil to produce this North Pole? Well, take your right hand and align your thumb or direct your thumb towards the North Pole. The fingers will show the direction of the induced current. In this case, it would be to the right as shown. There are 2 examples of Lenz's law and electromagnetic induction. More information can be found online in Unit 3, Section B, Activity 5. Good luck.